Welcome Algebra 1 students to our video where we will be practicing solving quadratic equations. We're going to listen to U2, Achtung Baby, for this video. I'll put the song's titles for you in the description. Alright, so let's jump in. At this point, you should have tried the questions that you see listed right here. So if you haven't, please stop. Or if you need to get them from the video, pause the video at each stage and try them, please. I do want you to have attempted the questions before you start seeing the answers. Okay, that's the whole point. All right, so let's get started. Okay, so we're going to talk about which methods we would use in order to solve each of these problems. And this is a big part of gaining efficiency and accuracy in what you're doing. I think it's important that you recognize that knowing which method to use that's going to be the best one is going to help you a great deal with what you're doing. So let's start with 23. Now, we're not actually going to solve them, guys. We're just going to talk about the method. So the first thing that I'm going to check each time is, can it be factored? Can I factor this trinomial? And we know that at this point we're supposed to find, and if we can factor it, we find factors of negative 15 that add up to 4. Well, those factors do not exist because negative 15 only has a couple of factors, negative 3 and 5, 5 and negative 3. That's going to be a sum of either 2 or negative 2. And then negative 15 and 1, and that would be a sum of 14 or negative 14, so that's not going to work. It cannot be factored. If that point it can't be factored, we could use completing the square. We could use completing the square here because the b value is even. So that would be a good method for this one. And if not that, the quadratic formula would be good too. I'm just going to abbreviate quadratic formula QF. Okay? All right, 24. What do you notice? What do you notice the lack of in that problem? If you look, you've got 9x squared and you got minus 49. There's no linear term. No linear term, that automatically means that you should be using square roots. Okay, so find square roots here. So that's isolate the x squared and so on. Okay, 24 strikes me immediately about number 25 is the size of the numbers. They are not small numbers. I would automatically go for the quadratic formula with that because I know that if I have to find, so I'd subtract the 73. Okay, so remember you want to get 0 on one side here, so you'd subtract the 73. But I automatically notice, whoa, those numbers are kind of on the big side. If I find AC, that's 4 times 73, so that's 280 and 292. So I might be able to find factors of negative 292 that add up to negative 41, but that's going to be daunting. You know, with a calculator it might help, but I don't think so. I think what I would do there is probably go ahead and do the quadratic formula. And I'm thinking that the same thing is going to happen with number 26, because if I'm looking at it, I'm finding factors of 9 that would add up to negative 7, they definitely don't exist. So I would quadratic formula that. Now I want you to notice that because of the 3 out front, and because that 7 is odd, it's not really a good candidate for completing the square. So I probably wouldn't use that. Number 27. I keep using, I know you probably have already noticed, I keep using the arrow instead of the pen tool by accident, but you'll forgive me for that. All right, x squared plus 4x minus 60. So I'd need factors of negative 60 that would add up to 4. So factors of negative 60 would add up to 4. So I would have to find factors of 60. 60 has factors 1 and 60, 2 and 30, 3 and 10, 4 and 15. Still not doing it for me here. 5 and 6. Oh, they don't exist. They don't exist. So I would use completing the square or the quadratic formula there. All right, last one of these. 28. Well, the first thing I want you to notice is that I can take one of these equations and I could multiply the entire thing. I could take this whole thing and multiply it by negative 1 and just as easily have 4x squared minus 8x minus 1. And that's actually okay, equals 0. You can do that. It doesn't change anything because multiplying both sides by negative 1 just switches all the signs. So again, I would look at, well, what do I have? I've got factors of 4 that add up to negative 8, or negative 4 that add up to negative 8. Those factors do not exist. The quadratic formula is going to be my best bet for that problem. So, of course, you can go through and solve these, but you'll notice that this was written with the intention that you would just talk about the methods that you would use to solve them. So it's probably not your best bet, because they're probably not going to be very happy answers for most of them. So let's jump into the ones we are going to solve. Okay, so again, do these first. So if you need to pause the video, go ahead and do them first, and then replay, and you'll see the work. Okay, let me get started. All right, number 35, I automatically noticed the lack of a linear term, and I also noticed that after I divide by 3 here, I do have w squared equals 16. That's convenient. And when I take the square root of each side, I end up with w equals, and remember what happens here, plus or minus 4. The plus or minus is there because there are 2 square roots of 16 technically. All right, so your solutions for this one are -4 and 4. Remember that we put the curly braces. Okay, curly braces, not parentheses here. Curly braces, not parentheses. Numerical order least to greatest. Let's try the next one. 36. All right, so first I'm going to look to see if I can factor it. So what's AC? Well, AC is -12, and I need factors of -12 that add up to 2, and unfortunately those don't exist. Factors of -12 that add up to 2 do not exist here because factors of 12 would only be 1 and 12, 2 and 6, 3 and 4. That's all we got. None of them would add up to a 2 if I switched the signs of one of the 2 factors. So I'm not going to be able to do that. So I'm going to have to quadratic formula this. So the opposite of 2 plus or minus square root of, let's see, b squared minus 4ac. Watch your signs inside that radical sign and keep an eye on what you plug in for a, because that number is usually a 1, but in some cases it won't be, and this is one of those cases where it is not. All right, so I gotta leave you just for a second. Sorry, get a calculator. All right, so -2 plus or minus square root of, we got 4 times 3 is 12 times 4 is 48, so 4 plus 48 gives me 52. So this is a problem where I am going to have to approximate, and when you're going to do that, notice in the directions they asked us to round to the nearest hundredth. So let's do that. So I have -2 plus the square root of 52, and I'm going to use my calculator. I'm going to hit enter and then divide by 6. Do the answer, divide by 6, and so I have one answer is 0.87 or 87 hundredths. Then I'm going to use -2 minus the square root of 52 and divide by 6. And that second answer is -1 and 54 hundredths. And recall from what we did in class that when you check that, you're not going to be able to get exact answers, or you're going to be able to get it to fit exactly because we approximated. As soon as you approximate, it's no longer exact. It's not going to come out to a nice, happy answer in the end. Next one. All right, number 37. Again, lack of a linear term. 6g squared minus 18 equals 0. We're going to add 18 to both sides to isolate the g squared. We're going to divide by 6 to get rid of that coefficient. And this one is not going to be a nice, happy whole number because the square root of 3 is irrational. But it is still going to be plus or minus. Now, if we were being exact, we would actually leave our answer like this. And this is something you're going to see in your next video. But we haven't learned about the difference between an exact radical and approximated radical, value. So I am going to go ahead and use my calculator to find the decimal values for it as well. So it's going to be positive and negative 1.73, 732. So we, and positive. Okay, oh, and I should probably do this. It's approximately equal to. Okay, so that takes care of that. So when you're finding the square roots, sometimes it'll be a perfect square inside that radical sign, and sometimes, like in this case, it will not be. All right, 3 more. Number 38. 3p squared plus 4p equals 10. Remember that I need to get everything on one side, so 3p squared plus 4p minus 10 equals 0. And I'm going to check and see if I can factor this. So, factors of -30 that add up to 4. I don't think I'm going to be able to find them. Frustrating and aggravating that keeps happening, but, you know, that's the way that these problems work. So let's go ahead and factor. The opposite of b, use the quadratic formula, since I can't factor. B squared minus 4ac all over 2a. Sorry, I know I should sing it, but I'm enjoying listening to you two, and I don't want to drown him out. All right, -4 plus or minus. So we got 16 minus 4. Now look here. Minus 4 times 3 gives you a -12 times a -10 gives you a plus 120. So that comes out to 132. Let me double check my math so that I'm not making a bunch of mistakes for you. Now, I want you to notice that when either A or C is negative, you will have a solution here. And this has something to do with our something called a radical. Oh, I did make a mistake. It's 136, not 132. All right, and the square root of 136 is not going to be a perfect square. So let's go ahead and add -4 plus the square root of 136. Enter, divide by 6. I'm getting approximately 1.28. And -4 minus the square root of 136. Enter, and then divide by 6. And that one's going to be -2.61. So I didn't put those in numerical order like I'm supposed to, or in curly braces, but I'm out of space. So we're just going to have to live with that. All right. Last two on this page, and then one word problem, and this video's over. 39. I like this one because I can already tell this one is going to be factorable. All right, what's the first step? Get everything on one side. So we're adding 4. Okay, and you don't need to write the +4 if you recognize that it's going to switch signs when it moves to the other side of the equation. So this is k minus 2 and k minus 2. Giving us the solutions when we use our zero product property of k equals 2 and k equals 2. This is called a double root. This is called a double root. And what's happening with this is if you were actually to graph it, the parabola only touches the x-axis at 2. Okay, so while we said there would be 2 solutions, sometimes that solution is the same number twice, and so you would go ahead and just give the one answer there. All right. Now, unfortunately, I'm out of time at the moment, so I'm going to have to come back to my video. So I'm going to pause YouTube here, and I will come back to the video shortly. All right, guys, picking up where I left off. Had a meeting. Now I'm back. I apologize for the change in audio. The heat's on now. All right, number 40 is the last one on this page, and we have a word problem, and we are done. 13r squared minus 117 equals 0. Oh, how convenient. Another one without a linear term. And I want you to recognize that that's really convenient because it's much faster. So I'm isolating my r squared, and I'm going to use my calculator because I'm pretty sure that's 9. But 117 divided by 13, yep, it's 9. Double checking. We're going to square root both sides. Yep, yep. And again, we're going to get plus or minus, and this one's 3. So r is equal to -3 and +3. And you know what? I haven't really addressed it, but graphing would have been a good method for this as well. We could have changed that to a y right there and graphed it. But since you're doing this video, at home, you're not going to have that part with you because most of you don't have a graphing calculator at home. So at this point, you would have to do it by an algebraic method rather than a graphical method. All right, one word problem, and this video's over. Now, it is a quadratic word problem, and we're going to have to actually write equations for it. So while I am hoping that you tried this is number 42 on that same page, 572, I think it's 572. And this is a little bit tougher to do than you might think. So let's go ahead and jump in. Your school wants to take out an ad in the paper congratulating the basketball team on a successful season. As shown below, the area of the photo will be half the area of the entire ad. What's the value of x? Okay. Well, the area of the photo, let's start with going ahead and putting that down. Area of the photo is 7 times 5. That's how we find the area of a rectangle, 35. Okay, so how can I describe the area of the entire space here, both of these dimensions? Well, the horizontal one would be 7 plus x. So this horizontal dimension is 7 plus x, or x plus 7, and the vertical is x plus 5. So the area of that entire space is x plus 5 times x plus 7. And they're saying that the area of that entire thing, that the photo is half the area of the whole thing. So this right here, this space is 2 times the area of the photo. Area of the photo. What would 2 times the area of the photo be? Well, 35 times 2 would be 70. Oh, not 75, 70. 70. And that's what we're going to solve. In order to solve that, we're first going to have to FOIL this left-hand side. So X, sorry, had a bit of an editing jump there. Hit the, hey, whoa. Nope, don't want that. Had a bit of an editing jump there. So I'm sorry, we're foiling this. And hopefully that's what you got. All right, equals 70. Now to solve it, we're going to have to subtract the 70 from each side. So we're going to have x squared plus 12x minus 35 equals 70. So we need factors of negative 35 that add up to 12. And sadly, they do not exist because 35 only has 2 pairs of factors. 1 and 35, 5 and 7. Neither one is going to work out that way because it is a negative 35. Okay? So we're going to have to solve this with the quadratic formula. Negative 12 plus or minus square root of b squared minus 4a and c. And because c is negative, we know that we are going to get rational number, not necessarily rational numbers, real numbers here, 2a. All right, so negative 12 plus or minus. I'm going to utilize my calculator for the more, the larger numbers here. Just being convenient. The inside of that radical comes out to 284. Which I do not think is a perfect square. Let's double check. Square root of 284, definitely not a perfect square. So I'm going to have to go ahead and use my calculator to find the 2 values. So negative 12 plus the square root of 284 comes out to 4.85 divided by 2. So our 2 approximate answers here. The first one is going to be positive 2.43. And then negative 12 minus the square root of 284. That one is negative 28.85 divided by 2, but I'm already seeing a problem. So here's our second answer, negative 14.42. Well, that's clearly not going to work because you can't have a negative length for an ad in a newspaper. So the value of x here ends up being 2.43 inches. So not easy to measure because inches, I'm not sure what 43/100ths of an inch looks like, so that would be difficult. But someone who works in a newspaper situation probably would easily be able to do that using computer layouts and so on. So that wasn't too hard a word problem. You'll see similar ones about the same level of difficulty over the course of the rest of the year. Hope you enjoyed this video. I'm going to go ahead and call it quits because it's probably a little on the long side. See you guys in class.